Today, we're diving into a high-stakes battle. But this one isn't being fought in a hospital, it's happening inside a computer. It's a fight between cutting-edge AI and one of the world's most devastating health crises, the stroke. And to really get why this is such a huge deal, we first need to understand the scale of the problem. Just think about this number for a second. According to global health data, 1 in every 4 adults will have a stroke in their lifetime. That is just a staggering statistic, right? It really sets the stage and shows you just how urgent this problem is. You know, when it comes to a stroke, everything, and I mean everything, is a race against the clock. It's this relentless countdown where every single second matters. And the finish line isn't just about treatment, it's about something way more powerful: catching it early. This quote right here really nails the problem. See, the real fight isn't just treating a stroke after it happens. The dream, the real goal, is to get ahead of it completely. And to do that, doctors need a whole new kind of tool, something that's reliable, super fast, and can dig through mountains of patient data to spot the risk long before it becomes a crisis. So, how do you even build a tool like that? Well, it helps to think of it like a new kind of crystal ball. Except instead of magic, this one is powered by pure data, and its whole purpose is to peer into the future of a patient's health. The technology that makes this all possible is called H2O AutoML. Honestly, you can just think of it as an AI expert in a box. It's an open-source tool that automates the crazy complex, super time-consuming process of building a machine learning model. And what that means is you don't need a PhD anymore to build something incredibly powerful. Essentially, H2O AutoML does all the grunt work for you. It takes care of stuff like feature engineering, that's just figuring out which bits of patient data matter most, and hyperparameter tuning, which is like fine-tuning thousands of little digital knobs to get the absolute best performance. It tries out all these different approaches, tweaks them, and then picks the champion, letting the humans focus on solving the actual medical problem, not getting stuck in the weeds with code. Okay, so let's pull back the curtain and actually go inside the AI factory. We're going to use a pretty simple production line analogy here to see exactly how a machine learning pipeline like this gets built step by step. So here it is, our production line. It's a pretty straightforward 4-step process. First, we bring in the raw materials, our data. Second, we scrub it all clean. Third, we send it off to the factory floor to actually train all the models. And finally, we do our quality inspection to see how well the finished product really works. Let's see it in action. All right, step 1, feeding the raw materials into our factory. Now, I know this screen looks a little intimidating, but don't get bogged down in the code. The important part is what's being loaded. Real-world, anonymized patient data. We're talking about the exact same things a doctor would look at: age, hypertension, blood sugar, smoking habits. This data is the foundation for everything our AI is about to learn. Step 2 is all about quality control. Because let's be honest, real-world data is messy. In this case, the system found over 200 patient records that were missing a BMI value. Now, instead of just tossing all that valuable data out, the pipeline does something really smart. It intelligently fills in those gaps using the average BMI from the rest of the dataset. This cleaning step is absolutely critical to building a reliable model. And now, for the magic. In step 3, H2O AutoML is just unleashed. Again, don't worry about the code itself, just focus on what's happening. The system is automatically building and testing dozens of different predictive models. These are powerful statistical engines with names like gradient boosting and XGBoost. It pits them all against each other and ranks them on a leaderboard. It's like a high-speed digital competition to find the single best algorithm for the specific job. So the model's built. The factory has produced its final product. But now we have to ask the most important question of all. How good is it, really? And that brings us to the digital diagnosis. So let's just ask it straight up. After all of that work, the loading, the cleaning, the training, how well did this AI actually predict the rest of a stroke? The answer is pretty much in this one number. The final model scored an AUC of 0.93. Now, AUC is just a way to measure how good a model is at telling the difference between two things. In our case, telling a high-risk patient from a low-risk one. A score of 1 would be perfect, and a 0.5 is no better than flipping a coin. So yeah, 0.93, that is an exceptionally strong result. This chart, which is called a confusion matrix, gives us the whole story. Look at the bottom right corner. The model correctly identified 100 patients who were at high risk. These are the true positives, and they represent potential lives saved. Amazing. But, and this is really important, look here. It also missed 100 patients who were actually at risk. Those are false negatives. And over here, it incorrectly flagged 78 healthy people, which creates false alarms. This just goes to show that no model is perfect, and the real-world challenge is to find that right balance, catching as many real cases as you can while keeping those errors in check. And this takes us beyond just this one project and points to what all this means for the future of healthcare. A future that isn't just reactive, but truly proactive. And here is what might just be the most amazing part of this whole story. This incredibly powerful predictive pipeline, it wasn't built by some giant corporation with an army of engineers. It was built by a team of students. And that just shows you how accessible these world-changing AI tools are becoming. So credit where credit is due to the people who actually built it. Team Delta. That's Fredy, Kiran, Rejul, and Mohd. They took this on to learn how AI gets built for real. And in doing that, they created something with the potential to make a massive difference. It's a perfect example of what happens when passion meets the right tools. So, we'll end with this thought. We've just seen how a small team can teach a machine to predict one of the world's biggest health crises with pretty remarkable accuracy. And that leaves us with one last big question. If we can do this for strokes, what should we teach it to predict next? The possibilities, really, are endless.